if you're an entrepreneur and you're thinking about doing a business, figure out what is it that will make people love it and what are the features you can say no to. It's almost more important what you say no to than what you say yes to.
Hello and welcome to the Being an Engineer podcast. Today we have Greg Mark, a visionary entrepreneurial innovator and the mastermind behind the invention of carbon fiber 3D printing. Currently the founder and CEO of Backflip, an AI company revolutionizing how we create 3D objects in the real world. Greg's career spans a series of groundbreaking ventures from Markforged, which redefined 3D printing to allow carbon fiber, to Genasun and Aero Motions, where his teams worked on off-grid solar power and high-performance aerodynamic solutions for sports cars. With a background in aeronautics and astronautics from MIT, Greg brings a passion for bold ideas, cutting-edge technology, and empowering people to change the world. Greg, thank you so much for joining us today.
It's a pleasure to be here. Thanks for having me.
Well, I first have to start off by talking about Markforged, because we have used Markforged machines for many years now. We love them. I'm a fanboy myself. And to be able to speak with you, the founder of Markforged, what a privilege. Just really cool opportunity. Thank you for being here.
Yeah, no, I'm happy to do it. It's funny because I was talking to a company out of Stanford that I'm mentoring yesterday. And the guy said, I just want to start off by saying, I got an Onyx One on eBay, and I use it for my side hustle, and I've made like 60 grand selling parts off it. I just turn it on and kick it off, and he's like, you pay most of my bills, so thanks for that.
Well, I won't make the whole episode about Markforged, but one thing that I have loved about those machines is that they're just bulletproof. You know, it's like this gentleman said, you turn it on and they just run. We've had so few failures on them, whereas other printers we used, it seems like failures are a little bit more common. But you just turn this thing on, it prints amazing parts, incredible surface finish, great tolerancing and accuracy, and they're robust, you know, just strong, chunky parts that are perfect for what we do, fixturing and automation, that sort of thing.
Yeah, you mentioned that a lot of your audience is, obviously engineers and looking to do machine design, things like that. A lot of what, Markforged kind of had a few different secret sauces, but if you actually spend the time to look at the machine, the design decisions we made in making the machine, Markforged, it's incredibly mechanically robust, and the machines are not over-constrained. So if you look at their design decisions, I'll give you an example. On the top plate of the Mark II Onyx One, the rails. So we designed this for the Marines. Okay, the rails are instead of being aligned with some fixture that you would have in the factory, we built these little dowel pins so there's dowel pins, small dowel pins, and then a screw with a 45-degree head. So when you screw those all down, it recesses the rail, pushes the rail to one side, because the alignment off one side gives you the tolerance to the CNC machine, as opposed to if you let it free float around and bounce off both sides, then you don't know where it is. We leave the pins in the machine. So if you, as a Marine or any other user that happens to be anywhere, or you in your garage, if you need to replace a rail, you can back those screws out, pop a new rail in, gently tighten the rails in the screw, then tighten all the dowel pins to recess it to one side, and you'll have a perfectly aligned machine again. Right?
I love that.
All the tools you need are built into it.
I love it. Now, speaking of repeatability, the build platform too, I really was impressed with the build platform and how that mounts. There are these they're not dowels, they're like conical pins, I guess you could say. And I forget what the repeatability was, the positional repeatability, but it was down in the microns for taking that platform off and putting it back on. Really impressive.
So it's called a kinematic coupling, and it's like really big in semiconductors. And what you do is this goes into the notion of constraint. So when you have an object to constrain it in space, you need 6 points to constrain it in space, and anything extra is redundant. And the problem with this redundant is, let's say if you're not sure what's going to hold it in place, every time you put the plate back in there, it might find a different thing to line it up, right? So what we do is we have basically a sphere, a cylindrical head on the bottom of the build plate, 3 of them, right? And then there's kind of a V groove, but it's in kind of a channel, an elliptical channel on each of the 3 mounting feet that are on the print stage. And what that does is basically it has like 2 points touch each screw. So you have 2 points on each screw, 6 points in total. Your thing is perfectly constrained, and every time you take it in, take it out, it's exactly those points touching it. So if you look at like a traditional 3D printer where you put a plate on, plate off, it's, any number of different points can be actually what's locating it. And so it's not repeatable. It's not precise. So by using this kinematic coupling, it's incredibly repeatable. And actually, I think we spec'd it to 10 microns, but it's repeatable to 5 because we always try to like under promise, over deliver.
Yeah. Yeah. Thank you for correcting me. Spherical, not conical pins on the bottom there, but a beautiful and simple and elegant mechanism for intense repeatability. So, all right, let's just not fight this. We started with Markforged. Let's keep going with Markforged a little bit longer. Tell us, how did you start Markforged? What was the story, the nexus of that company?
So it goes back to the Marines. So we love the warfighters and our friends in uniform. I was at a solar company, off-grid solar company, Genasun. And we were the world's largest maker of off-grid solar for, boats and science, then we had a huge deployment all over Africa and Antarctica, like really austere situations. And I was like, this is super cool. We should give this to the Marines. Like they should use this because they work all over the world. It's really harsh and, they need power. Right. So I fly down to Quantico, with these solar charge controllers and I show this to the Marines. And, this guy's like, he's like, Greg, he's like, this is really cool. Direct quote. He says, but Marines don't wire shit. We plug it in. He's like, so here's what I need you to do. He's like, I want you to make a hat for the battery that like plugs in the solar panel, and this hat clicks on top of the battery, and the Marine doesn't have to wire any shit or have any loose wires anywhere, and it just works. Right. And I was like, cool, I will have it for you in a week. All right. This was the first time I actually ever 3D printed. Okay. So my friends had a military company. They make the rope ascenders, like Batman rope climbing things. And they had just gotten a Stratasys printer. And they were raving about it. And I'd never used one before. And I was like, hey, can I come use this printer? So like, I designed the body for this thing in SolidWorks. And then I go to this printer and print it out. Okay. And it's like amazing, man. Like you can do like a 0 corner radius because instead of like CNC machining it, you're just extruding material out. So we do the whole process. I paint it black, of course, pot it. So it's waterproof. Send it to the Marines a week later. And they're like, fuck, this does exactly what you said it does. And all of a sudden we've got this cool military contract. While I'm printing this part, I'm sitting there thinking like, man, if this was made out of carbon fiber, instead of being a prototype for the Marines, it would be dumb. They could just use it. They could drive a truck over it. Right. So that's where the idea came from. It's basically, hey, look, like I can use, so I had spent a lot of time in composites from the race car company and actually from a power company in the past, learning about composites. So I realized, hey, look, if we just throw the continuous fiber in that prototype, it goes from a prototype to a production part the Marines can actually deploy. And that's where the idea for Markforged came from.
So Markforged machines have been used, I think, well, for sure the Marines, but even up in space. What are some of the coolest, most wild out there applications that you're aware of where Markforged machines have been used?
Okay, so my favorite is we're on the USS New Hampshire, which is a nuclear sub, a U.S. nuclear sub, right? We're the only 3D printer on a U.S. nuclear sub. And those boys print the hell out of this machine, right?
Really?
So they print everything with it, which is so fucking cool. And then of course there's parts of space stations. We have like fighter jet parts, commercial jet parts, kids use them for battle bots, which I love because anytime you have a chance to train the next generation, like you got to do it, right? Because like you had like, we're a snapshot in time, but humanity is like 300,000 years old. So we're just like the next step in the chain. So any time you can like train the new generation, it's killer. So my favorite thing about Markforged, and I'll tell you a funny story. My favorite thing about Markforged is the same badass carbon fiber printer when we came out with Mark II, same badass carbon fiber printer that NASA used is what high school students were making battle bots on. So it was totally democratized. It's not like if you had $1 million, you had a better printer than somebody who had $10,000. It's like you like to say the coolest possible tech we could do when we had the Mark II out when it first came out was in the desktop printer, right? And everybody could use it. And that was so fucking cool. So the other thing, going back to the Marines, so they run our stuff everywhere, right? And, I would ask them, I was like, hey, how can we make this thing better? And they were like, no, the printer works great. Like, it's great. I'm like, cool. But, I'd like to make it work better. Like, how can I make it work better? And this guy says to me, he says, Greg, he says, I've seen these printers fall out of trucks, fall off of trucks, get run over by trucks, get rolled around in the sand. He's like, I've taken an inch of sand out of the bottom of one of these things, stand over the rail, wipe the rails down, throw some WD-40, and we're printing again. He's like, your printer's great, dude. Don't worry about it. Right? So it's like, he's like, we love it, man. Don't worry about it. Right? So it's like, it's really cool. It's really cool the number of people who had great ideas and made their career with it. Right, I'll tell you one last story. There's a major food and beverage company, like major in this country. It's global, but headquartered here. And they had a person who just graduated school. Okay. And they were solving a major problem that they had with their food getting bad on shelves. And this engineer, he was like, hey, we should just print it on the Markforged. And his boss was like, you're crazy, right? Like, you're crazy. Like, we're this huge company. Like, we use CNC machines where it's crazy. And he's like, just, the printer's cheap. Let me try, right? So he does it. He prints the part. This is a key part. And then they start using it in like a test line. And it works better than the CNC machine parts. Okay. So they're using it more, they're using it more, they're using it more. All of a sudden they're now all converts. Okay. So now every item this company makes, the final quality step is done with like Markforged 3D printed parts. Because this person, this badass engineer, advocated for it, stood his ground, proved that it worked, converted his boss, then it converted the entire company. So every factory that makes this food uses his parts. Okay?
Wow.
Yeah.
Great story.
What do you think that did for his career? Right?
He's probably good things.
Yeah, he's the guy now.
Yeah.
He's the guy.
Yeah. That really resonates with me. We had a similar situation with one of our customers. It's not deployed worldwide, but with our customer, we design a lot of fixtures and things like that. And this company of ours, customer of ours, we came to them and said, we want to start using these Markforged 3D printed parts. And they're like, we'd rather have, machined aluminum or Delrin or stainless steel or whatever. And we said, well, just let us try it. All right. So we did. And what we were doing was these device holders. So previously, we would spend probably $2,500, $3,000, sending this out to a shop, CNC shop. They'd hog it out of a block of aluminum, a very nice contoured surface that matched the contour of these medical devices that we were fixturing, holding in this plate. And it would take probably 3 weeks, right? So now we try the same thing with the Markforged, and now we're printing it in a day, and it costs like the cost to our customer anyway was like $500, something like that, right? So like 20% the cost, and they get it in a fraction of the time. We deliver it, and we're like, okay, here it is. What do you think? And they're like, we love this. This is amazing. We had no idea. They now have multiple Markforged printers of their own, and pretty much all of their fixtures are made on Markforged machines now.
That is what happens. Like, it's like, that game Othello, where you put the pieces down, it flips from one to the other. Okay.
Yeah.
When a factory gets it, because you walk in and you see like aluminum everywhere, the shiny aluminum everywhere. Okay. Everything. Then when they get the Markforged printer, when they get it, all the fixtures turn black.
Yeah,
you just walk, everything is like, everything's 3D printed carbon fiber, the entire fucking everything. And we're just like, it's matte black, man. It is like, it's the new black.
And just to be clear, no one is paying me to say this. I've actually said really positive things about Markforged for years. I'm online. There are videos of me. I've actually worked with the marketing team at Markforged. I never got paid a cent for saying any of this stuff. I just really like the product. I think it's a great product. And so I tell people about it. That's been my experience.
Yeah. And actually at this point, I haven't owned a Markforged share in like 3 years. So and I'm not on any way. Nobody's paying me to say anything.
That's right. We are third parties.
But now I am 100% 100% third party.
Nice. Yeah. All right. So speaking of not being at Markforged anymore, you've got a new company called Backflip. What can you tell us about Backflip?
Okay. So it's really cool. So when we were at Markforged, we did the back half of design, back half of manufacturing. So you would design a part, and then you need to make the part. Okay. So you can, print it in, as carbon fiber, stainless steel, titanium, copper, you take your pick. Right. And then at Backflip, we're doing the front half of design. So if you zoom out and you look at the last 50 years, the major innovations have been on the design side. The difference between 2025 Porsche and a 2020 and a 2000 Porsche isn't the steel and aluminum it's stamped out of. It's the design, right? And so we said, hey, look, we want to move design faster. We want to be the next step change in the Industrial Revolution. And if you think about the Industrial Revolution, there's been many that, there was the first beginning, but there's been these additional ones. Like there was the first Industrial Revolution, then we had electrification, right? Then we had computers, and now we have AI. Okay. So we were in like an AI Industrial Revolution. And so, my co-founder, David, and I, we co-founded Markforged, and now we co-founded Backflip. We retired after Markforged because that was a journey. That was a very long slog. But we missed building so much. And we were like, man, we want to build like the design tools that we always wanted to have when we were doing Markforged, right? And we have a very unique approach for it. So the first thing that we're doing, is there's a scan to CAD. So you take a 3D scan and you get that point cloud of, 500,000 points, but you can't bring them into a CAD package or it will choke, right? And then you got to sit there and reverse engineer it by hand and you hate your life, right? So
and some people think reverse engineering is this magic button where you push a button and all of a sudden you've got this perfect CAD model. Not the case. Reverse engineering, even with the semi-automated, expensive reverse engineering software, is still a very manual and time-consuming process. So please continue. Sorry to interrupt.
No, exactly. And please jump in. So that's exactly right. So we've trained an AI model to do that step for you. So you scan a part and you create a mesh. Or, by the way, somebody sends you an STL, right? They'll take any mesh. You can take an STL. Somebody sends you an STL for whatever reason, for they rip it out. You can drop the STL into our AI and it will convert it into a CAD part, right? So it'll go, so there's two endpoints right now. The first one, which we'll be beta testing in about 2 weeks, gives you a step file. It'll be online. And we can get you in the beta, and you can drop an STL in and it will give you a step out, which you can then bring into any CAD pack, do direct editing on, right? And the second version is a SolidWorks plugin, which is super cool. And it will live in SolidWorks, and it will natively drive SolidWorks and create that exact part in SolidWorks with a SolidWorks feature tree. And it's a first-class citizen. So it looks like you CAD'd the part and you signed with your SolidWorks name, right? So this is really cool because, so it's very important. The philosophy for Backflip, okay? If you look at CAD, various CAD companies over the years, it's always been like a zero-sum game, right? When they go to a new company, they're like, hey, throw out your old CAD and use our CAD, right? Rip to replace, okay? We're like, we love CAD, keep your CAD. Okay, keep your CAD, you know it, you use it, you're great at it. You've got 10,000 hours in it. We don't want to slow you down a millisecond, okay? We're going to bolt on this turbocharger to the front end of this process, and we're going to get your idea into the CAD as quickly as possible through AI, and then let you rip through everything you're already great at. Take your pick, man. Your SolidWorks, Onshape, CATIA, NX, PTC, whatever you love to use, we love that you love it. We love that you love it. You know how to use it. You're trained on it. Your IT department signed off on it. Legal signed off. Keep your CAD. Okay? We bolt this thing in the front of it, and all of a sudden, we get your scan from like a crappy point cloud to a parametric part in a minute. Right? And then that's the first modality. We're going to keep adding different modalities on top of this model that will help you we will be the biggest on-ramp into CAD that's ever existed. And then the why. Okay, go for it.
I think that's a super smart model. I saw this AI drawing creation tool just the other day, right? 2D drawing. You drop a step file in, it creates a 2D drawing, all the dimensions, GD&T. Super cool, right? But I looked at it and I thought, I can't use this because it takes a step and then it gives me some proprietary output that doesn't play with SolidWorks, and we need to be compatible with SolidWorks. So the fact that you guys are supercharging the existing CAD tool that all of us engineers are already using, whether it's SolidWorks or Onshape or NX or whatever, that's a big deal.
Yeah, so for us, if you zoom out, the reason we as humans have nice things is because productivity per human goes up every year. Okay. Before the Industrial Revolution, we were in the shit. Okay. We didn't have nice things. We didn't have food. We were cold. We didn't have electricity. We had no computers, no cars, no airplanes. No, it did nothing. Okay. So the key to getting us out of that muck, okay, to have nice things was to raise that productivity per human. Because before that, for hundreds of years, we were just in the muck. Once productivity per human went up, we were doing great. So we look at the world and we're like, how do we increase productivity per human so we can all have nice things and live in the future? Right? Like that's how we look at it. And it's like, and it's like, we don't want to retrain people. I don't want to go in there and build an army of like retraining people. I don't want to rebuild CAD. I have no desire to rebuild CAD. Right? We're like, dude, because the modern CAD packages, they're great. They work really well. They're great. We just want to put a blower on that thing and just send everybody. We want to turn like a 15-second car into an 8-second car. Right? And it's just like, just hold on for dear life. And like, cause we want, dude, imagine if your car, the design cycle for your car was from 7 years to 6 years to 5 years to 4 years to 3 years. Right? It's like, dude, we're going to compress, we go through a time warp. We're going to compress time. Okay. And the cool shit that would normally have come out 50 years from now, we'll have it in 10. Don't you want a car from 50 years from now? I do. I don't want to drive the car from 10 years. I want to drive the car from 50 years from now.
I love this so much. My personal mission statement is to accelerate the speed of engineering to improve the human experience.
Yes.
You guys are doing exactly that. Exactly.
We're aligned. We're 100.
We're aligned.
And by the way, this is like, if you love people, which I do, like this is the best thing we can do for each other. Right? Yeah. You lift everybody up. Like when we invent cool things, we lift everybody up. It's so cool.
Yep. Yeah. So who is Backflip intended for? Is it for engineers, for consumers, for both, for some other category?
Okay. Two first user groups. Okay. Immediately obvious first user group. You're a CAD engineer already. You want to go faster. Okay. It's you, it's me. That's like probably half your podcast, maybe all your podcasts. Okay. You're a CAD engineer. You love CAD. You want to go faster. Okay. Or you're on the path to being a CAD engineer. You're learning CAD, and we're going to get you there faster. Okay. And I'll click on that in a second. But then there's a whole other, there's an entire other group of like mechanically brilliant people who like, and who I've got the pleasure to interact with in my years at Markforged. We would do this thing where, you mentioned use Markforged for tools and fixtures. Everybody uses Markforged for tools and fixtures. Okay. That's what the company does. We had this program called Walk the Line. We'd go to a factory, we'd walk down the production line and teach people what parts you can make out of Markforged and what parts you can't, right? And in this process, I would meet thousands of brilliant technicians and they'd be like, yo, I had this idea. And they'd tell me the idea and they could describe the idea, they could drive the idea. Dude, these people, they're building race cars, okay? They're overhauling engines. They're making furniture out of wood that looks like it came out of restoration hardware, makes restoration hardware look cheap, okay? They're mechanically brilliant. They're manufacturing your car. They don't know CAD. They just didn't have 10,000 hours to learn CAD. We're going to take those people and give them a tool to get them into CAD. Okay, so what's going to happen is like they're going to be able to scan, draw, describe their idea, and then get it into SolidWorks, get it into NX, get it into CATIA, right? Like get it into the CAD program of record. And we've made a very deliberate design decision. So when we create the file in SolidWorks, we don't just create the file in SolidWorks. We drive SolidWorks in front of you. So you watch how we made it. Okay. So you're brand new to CAD. You scan this thing in. Okay. And it's like, and you're thinking to yourself, how would I design this in CAD? Okay. This exact shape. And you've been thinking about it because you've been scanning it in. What is the extrudes? What are the cuts? What are the revolve? And then the AI will drive it, teach you in front of it. Here's where I do the thing, sketch. Here's where I extruded it, rotated it around, did this cut here, did this revolve. And it will literally it'll speed run it real fast, but it'll go through and build the entire thing. And you're like, that's how this part was built. So every time you make a part, it's showing you how it made it.
It's training and education.
It's training. There's built-in training in every time you use it. Okay. So here's the cool thing. So there's a leverage ratio. Okay. You own a factory, an automotive factory, and there might be one or two people who have CAD or can use CAD, and then 3,000 technicians, okay, who are mechanically brilliant. What if we let 50 or 500 of those 3,000 technicians get their idea into CAD? Okay. You know what would happen? The production line would go faster. Okay. And when a production line goes faster, company makes more profit, can hire more people, build more cars, have more efficiency, return money to shareholders, productivity per human goes up. And then, by the way, there's this quote, and I really wish I could find out who it is, but this guy he said, I've been working at an auto factory. He said, for 30 years, they've been paying me for my hands, and they could have had my mind for free. Right? So it's also like, man, it's nice to get your ideas out, right? When you have an idea, a good idea, and you can't get it out, it's almost painful to have that idea, because you know that the world would be better if your idea got into the world, right? And so, we're giving people a way to get their idea into the world, and it's not like shadow IT. We're not like, yo, here's this random thing on the side. We're like, no. It's in the CAD package. Okay. It goes in your native CAD. You can have a design review. You can have a part number. You can go through the entire quality control process. But now, instead of everything having the whole pipe, and now instead of the one or two engineers in the factory starting from zero, there's the technician comes and here's this thing I drew up in CAD. Right.
So
and it's in your CAD package. And why don't I pitch it to you? Why don't I explain it to you? And if you like it, we hit 3D print, and now we have it.
Have you ever wasted weeks fixing a design issue that could have been caught early, or struggled to find real, practical answers to manufacturing or tolerance stack-up problems? PDX 2025 is not your typical trade show. It's a hands-on engineering training event built for problem solving. Learn advanced CAD surface modeling, GD&T, DFM, adhesives and bonding techniques, metrology, and much, much more directly from subject matter experts in the industry. Bring your toughest engineering challenges, get live expert advice, and see real-world solutions in action. PDX 2025 is happening October 21st and 22nd in Phoenix, Arizona. Walk away with new skills that make you more valuable, help you grow your career faster, and even increase your earning potential. Spots are limited. Sign up now at The Wave. Democratizing CAD for everyone. Yeah.
Uh-huh.
Walk us through the process. How do you actually use this? If I'm a new user on Backflip, what are the steps that I go through to get my model into SolidWorks or whatever CAD package I'm using?
Okay, so we'll stick with SolidWorks because it's because you're a SolidWorks user, and we've announced a plugin, so we'll just go there. And there's a video of it online. We're plugin on the side, and it's Markforged black, right? So it's my favorite color. So it's plug on the side, and there's two buttons. Okay. One button is for import, right? And it'll tell you import STL, OBJ, whatever you want, you import it. And you'll bring in your STL, which could come from, again, a 3D print file or from the output from a scanner. Okay. And then we'll shoot it up to the cloud. Okay. Our GPUs analyze it. All right. Figure out what is the CAD sequence to make this part. And then we come down with 4 options, right? Because AI inherently has some variation, right? So we'll give you 4 options. Which of these 4 options is closest to what you want, right? And you pick that option, you can preview it, okay? And then you see that use a second button now. Send to SolidWorks. Okay, we're a third of the screen, right? Then it sends to SolidWorks, and then literally drives SolidWorks and rotates it and builds you your part. And that entire process, including building your part, it's a minute.
Wow.
Right?
Okay.
And then once you have your part, you collapse the window, goodbye Backflip, put it in the corner, right? When you need it, it's there. So we take up the smallest amount of real estate we possibly can because we don't want to waste your space. Right. And when you want to bring in an STL and convert it to a SolidWorks file, or you want to bring in a scan, convert it to a file, you click that tiny button, open up this beautiful window, really no training required, super simple interface. And then now you have your SolidWorks part. And then again, it's got a feature tree. So you can go in there and edit whatever you want to edit. Right. And the cool thing is the plugin you install, but the AI model gets better every 3 weeks. Just like Markforged software, just like, okay. So if you just take the summer off, when you come back, okay, your AI converter will be better, right? It gets better every few weeks.
I may have missed something here. You said there are 2 buttons. One is the import button. What was the other one?
One is basically, bring a file into Backflip, import, and the other is export to SolidWorks.
Export to SolidWorks.
So there's 2 windows. Okay. One is where 1/3 of it is the Backflip side, 2/3 the SolidWorks side.
Yeah.
You import, so you bring in your STL, it does the analysis, it comes out with a parametric model, and then you hit basically export to SolidWorks. The import's on top and the export's on the bottom, it's in blue. And it's like, and then that's what drives SolidWorks and then makes your thing.
Got
And
it.
it's
Okay.
watching it drive SolidWorks is so cool.
So that's amazing functionality. Is there a future where, you know how like with Dolly, right? It's text to image. Is there a future where there's text to CAD model?
This is a great and unknown question. Okay. So here's what I can tell you. We have a new, it's called a foundation model. We have a new AI foundation model, and it's like the world's first CAD model, and it's awesome, right? And it gets better every few weeks, right? And there'll be a series of inputs to it. The first input is this scanning. Okay. And another input is an STL. I just take an STL. Okay. We're currently exploring a range of inputs, but the major question is, what is going to help a either technician or CAD user get their idea into CAD really quickly? Is it text? Is it drawing on the screen? Is it drawing on paper and taking a photo? We're exploring all these different options with the goal there'll be a series of successive releases, the same way, the successive releases that help people get their idea into CAD, right? So they can make their idea real. Okay. And then which ones are the best ones? Nobody's ever done it yet, so we don't know. Okay. So I think like you can imagine a future where you say, hey, I'll give you an example. Let's say you're doing machine design. Okay. And you need an XY rail, right? You really shouldn't have to design that from scratch. You just shouldn't, right? It's kind of crazy. You ought to be able to say, give me an XY rail, and it should populate it for you. Okay. But then there are other things that are like really precise where if you're like, hey, okay, like the print nozzle, the print head for the Markforged printer, if I was like, give me a 3D print head, it will have no idea how to make a Markforged print head. Right. And then and those surfaces, those tolerance of dimensions, they really matter. Right. So in that situation, it's really about saving me clicks and getting from my idea into exactly what I want, like precisely, nothing different, what I want as quickly as possible. And we're candidly still figure that interface out. And that's why, what we did at Markforged, we did a few things. We invented new technology, and then we listened to customers. Like that was the secret. Oh, we had the best team. Okay. So invented new technology, had best team, listened very much to customers. And I'll tell you a story. So Onyx is a very popular material. Actually, I don't think I've ever told the story. Onyx you're hearing it first, very popular material. At the time when we started the company, we had continuous carbon fiber and what's called neat nylon. So nylon with no fillers in it. Okay. And the parts were all clear with carbon fiber in them. And honestly, they look like crap. Okay. Cause it's just not in carbon fiber, in traditional composites, we call it a gel coat. But the gel coat in 3D printing doesn't look good, right? It just doesn't. Okay. And I can tell you why it doesn't matter. Okay. So I was visiting a customer, a German auto manufacturer, because their Mark II had been kicked to Germany from Boston. Like it had fallen off the plane, it had fallen off the truck. They managed to, the shipper, and I'm not going to name names, bent the frame. Okay. Oof. By the way, you know the frame of this printer. It's an aluminum unibody.
Yeah.
Two humans, I know because I've been one of them, can jump on that frame and not bend it. Two humans can jump on it and not bend it. Marines have done horrible things. I do not know what this company did bend this frame. Okay. It's really, really fell. Okay. So I determined that the frame is bent. There's no way to fix this thing, so we got to send it to a new printer. And then the customer is like, Greg, I love your continuous carbon fiber, but there's a lot of times where I can't fit it in. And I'm like, yeah, I understand because we have an overhead of plastic on your side. He's like, and while I love the strength, my favorite part about it is actually it doesn't bend. And I'm like, of course it doesn't bend. Carbon fiber has zero coefficient of thermal expansion, in fact, slightly negative, but basically zero. I'm like, so of course. And then I was like, he's like, so can you just make it smaller? And I'm like, yes and no. Like, give me 3 months, right? And so make it smaller. So can we make it continuous carbon fiber toe smaller? No. But when I was like, so for the first year of Markforged, I was like, we're never doing chopped carbon fiber. It's a waste of time. It's not that much stronger, right? We're never doing it. It's a waste of time, right? And it's going to destroy the print head. Like, it's just horrible. Okay. You throw glass-filled nylon through an injection mold, it just tears it up. Okay. So I come back from Germany and I'm like, all right, boys, it's time to do chopped carbon fiber. Complete 180. Complete 180. Okay. Why? Because while I had originally believed that there was no application for it, as soon as we figured out there was, I'm like, it's a strong opinion held lightly, right? As soon as we saw the application, I'm like, well, I was wrong. 180, we were doing that as quickly as possible. We popped out Onyx in like 3 or 4 months. It was crazy. We shipped it over to those guys and they were like, this is exactly what we wanted. And then as soon as we started printing with Onyx, I told you, it's like that Othello thing. As soon as we started printing with it, we realized, dude, my co-founder David and the software team, they were always having to balance like too much cooling, too little cooling, parts warping, distort on all these different arbitrary shapes, right? By the way, doing all those different arbitrary shapes is why David now can make all the 50 million CAD shapes that we had to make to train Backflip. But anyway, so these things are bending and distorting. And then the Onyx comes out and I'm like, we're never printing neat nylon ever again. We're just like, the whole company went black. I was like, that's it. We will keep the neat nylon. There's no more support for it. We're 100% Onyx company. Like, it's like, if you need a non-marring wear surface, then neat nylon is cool. But otherwise, Onyx is just better material.
We love Onyx. I mean, probably 95% of what we print is Onyx. We have a Mark II, and so we can do continuous carbon fiber, and it's great for the 5% of the time we need it.
You got it.
But, the Onyx is pretty remarkable on its own.
What I tell people is it's like a pickup truck. Okay? When you're in a pickup truck, you're not loading the bed all the time, right? The continuous carbon fiber, you don't need it all the time. When you need it, it's amazing. Yeah. Right? But like pure, what it is. And obviously I spent time thinking about this. When you make an aluminum part, most of the time it's over-designed. You didn't actually need all that strength. And so as an engineer, before 3D printing, the base material that we kind of thought of was aluminum because it threads so nicely. It doesn't thread as nicely still, but it threads so nicely, okay? So it's like, well, you make it out of plastic with a plastic bend. It's hard to hold a device. It's hard to clamp on it. The threads are shitty. Like, you're like, unless you're using like Ultem, which is a cool plastic. Otherwise, you don't want a CNC machine like nylon. It's not worth it. You're going to machine it, might as well be aluminum, right? So we just, as a machinist, we just all think about aluminum, right? And then once you get used to Onyx, you're like, wow, I've been over designing a bunch of stuff.
Yeah, right.
And that's when you realize you can like dial it back.
We had an experience one time where we were delivering a machine or scheduled to deliver a machine, and a part, I can't remember if the part broke or we didn't, I think we didn't get the part in time, and we were supposed to deliver this thing the next day. So we were up late trying to figure out, what do we do here? And we said, let's just print it on the Mark II and stuff it with continuous carbon fiber. It was an aluminum part that we needed, and we really did need it to be very stiff and rigid. And so we stuffed this part with continuous carbon fiber. We had it ready at like 3 a.m., right, that morning, and we put it on our machine and boom, worked perfectly. And that's how we delivered it to the customer. So it was a pretty awesome solution.
That is the exact story. It is a, what I call a wartime solution. Okay. So when there are rules for what you're allowed to field in the military, and there are wartime exceptions. Okay. Because they're practical. Okay. This is the same thing for us for engineering, man. It's like, you would never have shipped that out of aluminum, but you had to, right? You would never shipped in carbon, but you had to. And then people try it works. And all of a sudden it's this light bulb moment. And we did it ourselves. We were designing these printers. One of our engineers, I was like, he was going to CNC machine a part. And I was like, why don't you 3D print it? And he looks at me and it's late. We're all tired. And that's when he goes, because I need it to work, dude. And then he just realized that he told the CEO that he needed, and he's like, okay, I'll try to print. I was like, dude, I'm happy to watch you CNC this thing. But, it takes like 30 seconds to get off on the printer. Just try it. See what it does. Okay. So he kicks the print off, and then he's coding the thing. He's setting the fixtures. He's got the first op done with the machine. While he's getting the first op done, it's a 3-op part. The 3D printer part finishes. He picks it off the printer. It's a spool holder. And he's like, puts it in the spool. He's like, wow, it fits. And then he puts like the maiden piece into it. He's like, oh, it fits too. And then he puts it on the machine. He's like, oh, it holds the load. And I look at his face. And he was like, and it was like he discovered fire. He was like, holy, and dude, then he 3D printed everything, right? We, as humans, we need to feel it. that intuition. We need to believe it. We need to believe it can work, because it's all, especially mechanical engineers, everything is a theory that we don't trust until we feel it. We see it for ourselves, because the world relies on mechanical engineers to build things safely. Okay. We're like the gatekeeper of safety. We're like Captain Safety for the entire world, right? So the world needs us to be conservative, because we have, we're the safety people. Like, we make your cars safe. We make your planes safe. We make your buildings safe. Like, we make your bridges safe, right? So mechanical engineers, it's ingrained in us. Like, I have to really feel it and see it and analyze it and stress test it and bend it to believe it. But then once you have that thing, it's this big unlock, and you're like, oh, I can make stuff faster. I can make stuff more effectively. I can, solve problems. It's like superpower.
In a funny way, that story reminds me of my kids eating my wife's cooking. They're always like, no, I don't want to eat it. It's gross. I don't like this, blah, blah, blah. And then they eat it and they're like, oh, that was actually good. I can eat mom's cooking. Yeah.
Light bulb moment. That is, people don't, it's like the green eggs and ham, man. It's green eggs and ham. Right.
Perfect. Yeah. All right. Let's talk a little bit about, entrepreneurship and starting businesses. So you've founded multiple companies at this point. How do you go about evaluating whether an idea is worth putting the time and effort into really building a company around?
That's a great question. It's funny. So the first thing is, the first question is, imagine that. So as an engineer, or the first time to start a company, you get really focused on, can I build it? Right? And there's a trick that you have to learn from venture capitalists. And the trick is, they just assume you can build it. And sometimes this causes them giant disasters. Okay. But they're just like, okay, let me assume you can build it. Does anybody care? Okay. There's a Netflix documentary called Something Ventured. If you want to be an entrepreneur, you got to watch a documentary. It's about the history of venture capital, and it's a great documentary. But the things you want to do, the first question is like, let's say you build this thing. How big is the market? Does anybody care? Does anybody care? And how much will they pay for it? And can you build a business out of it? So the thing with building businesses, you've got to be able to fund the business in a scalable way. Okay. What does that mean? Like, it's like, okay, Markforged hit break even, or we're doing 30 million of revenue. Every dollar we made of profit, we pumped back into the business. Every dollar. Like, there was no like profit distribution at the end of the year. Right. And so if your business is profitable and growing quickly, you can invest in R&D. If your business is not profitable and growing quickly, you cannot. That's just it. Okay. So what you want to do is so there's this balance. You need to price it high enough that you can make enough margin that you can actually grow the business. And you price it low enough that when the customer looks at it, they're like, I get incredible value even after having paid that. Right. And so you got to balance that right. So it's like, you need to make a product that people are going to love. You need to be able to sell it for a high price, low enough that they can afford it and it makes their life more efficient and better, but high enough that you can get what's called free cash flow to pump back into the business, to hire engineers, hire product managers, hire salespeople, hire the finance person to keep the books, hire the lawyer to make sure you're not getting sued. Like, you got to pay all these people, and that comes from the profit, right? So the thing, and there's a funny thing where 40 years ago, people would build an entire product, the marketing, the packaging, the entire thing, and they would launch it. Right. And then, 20 years ago, people had this notion of minimum viable product. Like, let me get the product to the market quickly and see if people care. So you spend like half the time building it, half the cost, whatever, maybe even less than that. And then you ship the first thing. Like the Mark I, it wasn't perfect. By the way, neither was the first iPhone. And it actually, one of my favorite stories, the first iPhone didn't have cut, copy, paste. Like a basic ass feature, cut, copy, paste, absent from the first iPhone.
I had forgotten about that, but now that you mention it, I remember that. Okay.
But people loved it. Okay. And that's the magic. And there was this like, so I had a friend working at Apple, and, because the previous version of the iPhone that never shipped, they were all ready to ship this thing. And Jobs is playing with it. He's talking to Johnny, and he's like, I don't love it. And Johnny's like, I don't love it either. And Jobs is like, fix it, man. Right. And fix it was a very expensive. This is not a trivial thing. This is like a really fear inducing thing. It's like, you're tooled up, your factories are ready, your marketing is ready. And Jobs is like, nope, you're going to have to go in another direction because I just don't love it. Okay. And the key point here is they got to something that they loved and we all loved. but it was an imperfect product. So you've got to figure out what can be imperfect about your product, but people love it. Okay. So, I'll give you another example. Enzo Ferrari. Okay. The entire time he lived, the body panels on his cars never lined up worth a damn. Right. And he famously said, somebody was complaining about this, and he said, I don't care if the body panels line up. When the driver steps on the gas, he should shit his pants. Right? Okay. So what is Enzo telling you? Enzo's a product manager. He has an intuition. What is he telling you? He's telling you, I have limited resources. Okay. I have limited resources. I got to put them somewhere. Am I going to put them into hiring people to do the Toyota thing and make everything perfectly lined up? No. I'm going to put all my money into the engine, and my engine is going to sing. And when you step on the gas, you're going to shit your pants. Now, Enzo also had great handling, great suspension, but he knew there were things that he could get away with. Okay. Features that like people would want, but they don't really need. And if he really focused all of his chips on this other thing, he would have a very special car. Right. And so you've got to figure out in your chosen profession, in the product you want to build, what is the essence that's going to make somebody love it, and they need that thing, and you want to double down on that essence. And what are the things that you can I'll give you an example. What are the things you cannot ship? I'll give you an example. Markforged printers print slow as hell. Okay. They're faster now. Okay. But when we started, everybody asked them to make print real faster. Okay. Cause it's like watching grass grow. And I was like, no. Okay. I was like, we don't have enough people. We're going to focus on reliability, because if you're it goes back to the thing, mechanical engineers, we're in charge of safety and repeatability. So I was like, I should tell our engineers every time this came up, like, you know how fast the world's fastest carbon fiber 3D printer prints? That fast, right? As fast as, okay, we're the bar. Okay. Now, whether or not somebody loves us is not if the part finishes 20 minutes earlier. Okay. It's if it works. And way back in the first few years, we'd have part failures. Okay. So if you print out a part, you go home, you go to sleep, you come back, and you got a spool of trash, of a bird's nest, you're very unhappy. Okay. If it took 20 minutes longer, you're totally okay with it. The 20 minutes longer, cut, copy, paste. Bird nest, don't love it. Right. Once we said, I'm going to not move all the variables. We're going to print this exact same speed and focus all of our effort on reliability. Everything we got, we're going to make it reliable across the entire range of parts. If you get a part that you can't print, you have to get the support button. We figure out how to print it for you. Right. And then we print for you and everybody else. Right. Like we update the algorithm, everybody gets that part. So we really obsessed over getting you really strong parts reliably that you could depend on. Right. And then once we got there, then we started making it go faster. Then it went twice as fast. In fact, like that was the order of operations. So if you're an entrepreneur and you're thinking about doing business, figure out what is it that will make people love it, and what are the features you can say no to. It's almost more important what you say no to than what you say yes to. Okay, you got to say yes to like one or two things and no to 10 things. It's like a 10 to 1.
Well, I just found the intro to this episode right there. That was perfect. Incredible insight. Fantastic insight. Thank you so much for sharing that. I have so many more questions that I want to ask you, and we're not going to get to all of them. Let me just end with this last one here. You had a really cool experience as a senior, I think in high school, getting a job making custom bicycle frames.
Yeah.
And it demonstrated your ability to be persistent. So the question here is, first of all, can you share that story briefly? And then to what degree has persistence shaped your career as an entrepreneur?
Oh man, my mentor once said, in our society, persistence is heavily rewarded. Not in all societies, but in our society. Okay. So, I was a bicycle mechanic at the time, and I wanted to make these custom bicycle frames. And I had signed up at my school, to take 2 periods off to go do this internship. Okay. Assuming that I would get it. Having never talked to the people who actually had to say yes. And so, cause how it goes. So school starts and I show up and I'm like, hey, I want to do an internship. I hear you do this thing. And the guy goes, Dave Ross is his name, really good guy, great guy. And he says, Dave says, dude, we only take like college grads, maybe a college, you're not a high school kid, right? And I'm like, no, man, like, I'm going to work really hard. I would fix bicycles. I'm good at fixing bicycles. I'm going to, I'm like, you don't have to pay me, dude. I'll be free. Da, da, da. I'm negotiating against myself. I'm like, I'm free, man. You don't have to pay me. I'll sweep the floor. I'll take out the trash. And he's like, no, dude, no. Okay. So I'm like, fuck. So I get in the car and I go home and I'm like, I'm really fucked right now. And then like my school teacher is like, hey, I need you to, your internship advisor sign this thing. And I'm like, funny story, right? So I'm like, so fucked. So I didn't have a choice, man. So I got to go back. I go back the next day and I show back up. And he's like, what are you doing here? I'm like, dude, I really need this job. like, I don't know about you, but like, it's life and death for me, man. Like, I need to work here, right? I need to be here, right? I was like, look, man, like, okay. So then he lets me try. Okay, lets me try. My first day, I have never fucked up so much in my life. Okay. My first day, I'm sweeping the floor. I'm doing stuff. This is fine. I'm working there for it's supposed to be a 2-hour internship. I'm there for 5 hours every day. Okay. So like maybe more. And then I've got to drill this water bottle hole. Okay. So if there's a fixture, the first fixture I've ever used, and it's got like little bushings and a fixture and you drill it. Okay. Then you rotate it, you slide it down so the water bottles can be, offset from each other on the down tube. Okay. Well, I drill the hole. I slide it over. I don't index it down. So I drill the hole exactly opposite from each other. And it's like, I got a fucking hole in a bicycle in the wrong place. And they've got to fill in that hole. And at the time I don't weld. They had to weld it, fill it in, grind it down, and, reheat treat the bike. Okay. So it's like, fuck, man. Okay. And then I fucked up a serial number. Dude, I think because I was stressed because I fucked the hole up. It's like, again, this never happens to me. Okay. And and then Dave, to the kindness of his heart, he's like, you had a bad day. And I'm like, I had a really bad day. And he's like, I'll give you one more chance. And he did. Right. He was a great guy about it. And then I became a great employee for him. I kicked ass. I worked hard. I was cheap. We did a bunch of stuff and it was a great relationship for all parties. So he's a great guy. But what I would tell you is, man, it takes a lot of no's to get to yes. And by the way, cause your podcast is being an engineer. Engineers have a love-hate relationship with salespeople. Okay. But if there's one thing that engineers should really learn from salespeople, a good salesperson knows that there's 10 no's for every yes. Okay. And you cannot let the no stop you. Okay. You get a no, customer says no. You do I hope this is a no for now and not forever. And you come back. Give your no, hope this is a no for now and not forever. Okay. And if you have a good product, and you're a good person, often that will turn into a yes.
Fantastic. Such great advice. You said something else at the beginning of that story that struck me as being an important mindset for an entrepreneur. You said that you didn't even have this job, this internship with the bike company when you told your school that I need 2 periods off so I can go do this. And I think that is entrepreneurs. I think that we often just assume that we can do this thing. Like other people assume we can't do that because of A and B and C. But entrepreneurs often have the mindset that I don't know how to do this, but I assume I can figure it out. I assume I can make this work. And then we just move forward and we figure it out.
Yes. And I think it's like the words are suspend disbelief. Okay. So an entrepreneur shares a lot. If you look at the Venn diagram of entrepreneur and crazy person, there's a fair amount of overlap. Okay. This entrepreneur believes in a future that does not exist yet, that is incredibly hard to achieve. Okay. And they live in this reality where they think that's going to happen. This crazy thing is going to happen. Okay. And you just have to suspend disbelief. And here's this great Steve Jobs quote. He says, the people who are crazy enough to think they can change the world are the ones who do.
Amen, brother. I love that. Greg, thank you so much. This has been a phenomenal hour. Thank you for sharing your time with us and your wisdom and your insights. I think a lot of people are really going to enjoy this episode and benefit from it. Is there anything else we haven't touched on that you'd like to leave us with as we close out this conversation?
I think this was great. I think you asked great questions and I'm glad you're happy with your printer. And I hope you get to, I'd love to hear your feedback on Backflip. And I think you're going to love it.
I'm looking forward to it. Thank you, Greg.
All right, it was a pleasure, man. Let's do it again sometime.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.